Hello, welcome to lesson 9 on the topic time and work. As I said, towards the end of lesson 8, we are going to look at one more very good example of the application of negative efficiency, right? So let me first begin with that example. Please listen and understand very carefully. A pipe is able to empty a tank in 30 hours. Alright. A pipe is able to empty a tank in 30 hours. Okay. But it takes 0.5 hour more because of a leak. This is a beautiful question. Okay, you have done something similar, but this question is very good, right? But it takes 0.5 hours more, because of a leak. Now, there are two questions that can be asked. In how much time can the leak alone empty the tank? In how much time can the leak alone empty the tank? So this question we have discussed earlier, something similar. And the second is, if the leak drains out water at the rate of 2 liters per minute, then what is the question? Find the capacity of the tank. Usually it is part B which gets into some of the good competitive exams, and students suddenly find this question difficult to handle because they are not able to anticipate, they are not able to comprehend or understand the problem and come to the conclusion what is being asked. A very good example, a very simple example. Let's get into the solution. The pipe can fill the tank in 30 hours and the pipe and leak can do it in 30.5 hours. Now suddenly I have got a decimal value, first challenge. Okay, so what is my suggestion? Let this be 30, convert this into 61 by 2. Alright, I hope this is clear. Convert this into 61 by 2. Now what do? Let me take the total work as 61 units. To make things easy, you will be able to realize soon. Let me take it as 61 units. So how much is the pipe able to fill? 61 by 30 units per hour. And how about the pipe and leak? They are able to fill 2 units per hour. Okay. So the pipe alone is able to fill 61 by 30 units per hour, but along with the leak, it is able to fill 2 units per hour. I am sure you know that 2 is less than 61 by 30 because the leak is obviously going to empty some water. Therefore, how much is the leak emptying? It is 61 by 30 minus 2. So 61 minus 60 by 30. So it is able to empty 1 by 30 units per hour. Alright. The leak alone is able to empty 1 by 30 units per hour. Now what is the first question? The first question is, in how much time can the leak alone empty the entire tank? So 61 divided by 1 by 30, 61 into 30 by 1. What is this answer? This answer is 1830 hours. So this is the first part. If you remember the earlier lessons, I think we had taken it in the last lesson. In lesson 8, we had done a question like this. Okay, so fairly simple. Now, what about the second question? What about the second question? Please read the question again. If the leak drains out water at the rate of 2 liters per minute, then what is the capacity of the tank? Now, something very interesting to understand. The leak alone is able to empty the tank in 1830 hours. Now, therefore, in 1830 hours, the volume of water that is drained out by the leak will be equal to the capacity of the tank. I hope I am making sense here. I'll repeat it. In 1830 hours, The volume of water that is drained out by the leak is nothing but the capacity of the tank. So if you have understood this once, then it's very simple. So the leak drains out water at the rate of 2 liters per minute. Okay, 2 liters per minute. So per hour, how much water will be drained out? In 260. Okay, so it is 2 liters per minute. Per hour, how much water will be drained out? In 260. And in 1830 hours, how much water will be drained out? Multiplied by 1830. So what is the capacity of the tank? 2 into 60 into 1830 liters. I leave the final calculation to you. I'm sure now you can do this. And that will answer the second question. What is the capacity of the tank? Okay. So children, this was another example. I hope you have understood this clearly. If not, you can go back and once again revisit this example. We come to the last part of our discussion on the concept of individual efficiency, and then subsequently we will move to the application of group efficiency. Now this is going to be very interesting. What is this? This is the combination of alternate. This is the combination of alternate and negative efficiency. A very beautiful example. A beautiful trap, I must say. A very good question. Okay. Let's discuss this by taking an example. We'll discuss this by taking an example. Pipe 1 can fill a tank in 20 hours. Pipe 2 can fill the tank in 30 hours. I'm sorry, it is getting filled, so 30 hours. Whereas a leak can empty the tank alone in 60 hours. So pipe 1 can fill the tank in 20 hours, pipe 2 in 30 hours, whereas the leak can empty the tank in 60 hours. Now, they are working one in each hour. Alright, you must listen very carefully. They are working one in each hour in the order. In what order? P1, then P2, then leak, then again P1, then P2, then leak, and so on. What is the question? In how much time will the tank get filled? Okay, in how much time can the tank get filled? I hope all of you are focusing on the board. Now, what we will do? We will take this as 60 units. So this is 3 unit, this is 2 unit, and this is minus 1 unit. Alright? Now what happens? What have you been told in the concept of alternate? You have been told that take 1 day's work or 1 hour's work and combine everything. So what we will do? We will say 3 plus 2 minus 1, that is 4 units fill in 3 hours. Alright? 4 unit filled in 3 hours. What is the next thing that I had told you? Go to a multiple of 4 closest to 60. Less than or equal to 60 but closest to 60. Right? Now what is the multiple of 4 closest to 60? A multiple of 4 closest to 60 is 60 itself. So 15 cycles. Therefore, so 4 units in 3 hours, therefore 60 units, that means we are talking about 15 cycles in 15 into 3, that is 45 hours. Now this is the answer that most students would get. I am sorry to share with you that this answer is wrong. Alright. Now let me very quickly do some sharing with all of you. Will it be wrong if all these efficiencies had been positive? No. If you remember, I had told you, if everything is positive, go to the actual multiple also, if it is possible. Right? But then your question would be, why is this answer incorrect? I would want to ask all of you a simple question. Who is working on the 45th day? the leak is working on the, or rather 45th hour, the leak is working in the 45th hour. What is the leak? What will the leak usually do? Will it fill or will it empty? It will empty. Now please remember this. This is very, very important. Please remember this. In case of the concept which is a combination of alternate and negative efficiency, the entity with negative efficiency cannot finish the work. Very logical. If the person who is having a negative efficiency, if that person works in the last hour or on the last day, do you think the work will actually get finished? No. And therefore, this is a mistake. Therefore, this answer is wrong. Please don't do this. And let me tell you, whenever a problem like this is made, it is created so that students fall into this trap and make this mistake. You have to be very careful not to do this. So what should be my approach? My approach should be 4 units fill in 3 hours. Go to a multiple of 4 such that the remaining work gets completed only by the positive efficiency entities. I repeat, go to a multiple such that the remaining work will get completed only by the positive efficiency entities. The negative person does not get a chance. So what should I do? 4 units fill in 3 hours. Therefore, 56 units, that means 14 cycles, will get filled in 14 into 3, that is 42 hours. Alright. So 56 units in 42 hours. A quick example. Why 56? Because from 56 to 60 you have only 4 units remaining and the positive people have a capacity to finish 5 units. Right? So the negative one will not get a chance now. So 56 units in 42 hours. Who will come on the 43rd hour? P1. So in the 43rd hour, P1 will come. P1 will fill 3 units. So 59 units will get completed in 43 hours. Who will come in the 44th hour? P2 will come. How much work remains? 1 unit remains. How much can P2 contribute? 2 units. And therefore in the 44th hour, P2 will come and 60 units will be completed in 43.5 hours. Alright. So the answer to this question, that is 45 hours, is not correct. It's a trap. What is the correct answer to the question? The correct answer to the question is 43.5 hours. Alright. Let me very quickly share with you that this is a thought. This what we have discussed in this example is a thought, and it is actually used by examiners in many situations. Let me give you a very popular example. A monkey is climbing a 60-meter pole. A monkey is climbing a 60-meter pole. In the first second, it climbs 2 meters. In the second second, it drops 1 meter. In the first second, it climbs 2 meters. In the second second, it drops 1 meter. Now, the question that is asked is, in how much time will the monkey touch the top of the 60-meter pole for the first time? In how much time will the monkey touch the top of the 60-meter pole for the first time? Now, let me tell you, students, this is nothing but the same concept being applied in a different question. What is the answer? I would leave it for you to find out. But please remember not to make the same mistake. Right? With that, we come to an end of our discussion on all the different types of questions on individual efficiencies. In the subsequent lesson, we will start talking about and discussing the problems of group efficiency. Thank you.